So the distributive law is a very important law in mathematics. We'll use it just about every day. So here's what it looks like. I have the letter A, and then notice it's right up next to parentheses. And remember what operation that implies, right? That's how we can signify multiply. So it's A times, and then inside the parentheses I have an addition, A plus B. So I want A to multiply everything inside the parentheses. So the way we say that is A times B plus C. So it means A times B plus A times C. So whatever number is out in front, it could also be back behind, but if you have a letter or a number multiplying a set of parentheses with a plus sign or a minus sign, that number needs to multiply all of the pieces inside. Okay? I've shown it here with just two inside, just two terms inside. It could be 3, 4, as many as are inside. The number out front multiplies all of them. Okay, so let's go ahead and practice. So the verb will be distribute, maybe simplify, maybe multiply, right? All of those verbs would have you. So in this first case, it's 3 times the quantity, 2 plus x. So we'll do, and sometimes I'll draw these little arrows in. So 3 times 2 plus 3 times x. Okay, and then 3 times 2 is 6. And 3 times x, well, that's just 3x. Nothing else to be done there. What about the next one? I have A times the quantity. I say the quantity when I get to the parentheses. A times the quantity, x squared plus 7x. So again, the A is going to multiply both things on the inside. So this is the same thing as ax squared, A times x squared, plus A times 7x. Okay. Now typically for that second term that I just wrote, we would not write A times 7 times x, we'd put the number first. So I'll go ahead and rewrite that in a more conventional way. Ax squared plus 7ax. Nothing else to be done there. So real quick, I've used a couple of vocabulary words I want to make sure you understand. So the first one is factor. So factor is part of a product. And remember, product is the result of multiplication. Okay? So factor versus term. So term is part of a sum or difference. Right? I've only used addition in my examples, but it could also be, right, difference goes with subtraction. So just to point out up top here, they're also nested, right? So factors can have terms and terms can have factors. So go ahead and take a deep breath. So let's look right here and identify some of the pieces. Okay. So this letter A out front is a factor because it's A times this other quantity, x squared plus 7x. Now, x squared plus 7x, the entirety with its parentheses is also a factor. But inside that factor, I have two terms. Okay. So within that factor, x squared is a term and 7x is a term. And then within the 7x term, there are two factors. Within that term, 7 is a factor because it's 7 times x, right? And x is a factor. So if it's part of a multiplication, it's a factor. If it's part of an addition, it's a term. Okay, so one of the ways that we get to use the distributive law is backwards. So distributing, we go forwards. Factoring, important verb for us, we go backwards. So when we factor, we are looking for a common factor for all of the terms. So in my first example, I have 8x plus 6y. So I'm thinking of a factor that goes into both 8x and 6y. So I'm going to write a little gory detail because it's kind of good to see where it comes from. So, right, did we all come up with 2? Okay, so 8x I would write as 2 times what? 8x is the same thing as 2 times, right, 4x. So then how would I write the 6y? 2 times what? 2 times what is the same thing as 6y? Right? And you can figure it out by dividing, right? If it doesn't just jump out at you, go ahead and divide 6y by that common factor 2. You get 3y. Okay. So now, right, just like above when we distributed, can you still see that? Right, there's the 3 that multiplies both parts. So same thing here, but we're going to go the other way. So there's the 2 that's the same. So grab those 2's, factor them to the front, and then we gather the other pieces. So 4x plus 3y. Okay. So these are equivalent. 8x plus 6y is equivalent to 2 times the quantity 4x plus 3y. So when we go in this direction, it's called factoring because we take these 2 terms and turn it into a multiplication. So let's try this last one. What number goes into all 3 of those terms? 12a plus 18b plus 3. And once you decide, one way that you can make sure you get everything right is to go ahead and write each of those 3 terms as that common factor, exactly 3 times the other part. Okay, so 12a, 3 times what? Right, 4a. 3 times 4a is 12a. 18b, 3 times what? 3 times 6b. Oh, that's unfortunate, 6's and b's together. Keep yours separate, maybe do capital B's or something. Plus 3. So I included this one specifically so that you see what to do. So when we add that 3, I still needed to have that common factor of 3. 3 times what? Exactly, 3 times 1 is the same thing as 3. Now I have that common 3 in each of the terms. So we go ahead and factor it out. And then we gather up those pieces right that were left. So 4a plus 6b, I'll do my capital, plus 1. And you can always check by distributing and seeing if you get back to where you were. So quickly, I just noticed I was saying that factor is a noun and a verb. Right? So factor, noun, part of a product, or verb, that action we take when we rewrite it, when we pull out the common factors. That's called factoring, or as a command, factor. Okay, good luck on these.